Hello and welcome to ASTA Academy series of SAT lectures. Today we are going to look at linear equations in one variable. On SAT, you can have different types of problems, which you can solve either in one step, two steps. You may have equations with variables on both sides. You may have equations with the distribution property to be used, or may involve fractions. And there could be some special cases of no solution or infinitely many solutions. So let us look at the first example of how do we solve an equation in a single step. All right. So let's say you have something like this. X plus 7 is equal to 15. Very simple, right? So you take the 7 on the other side and you will have the value of x. That will be x is equal to 15 minus 7, which is going to be 8. So that means your x is equal to 8 is your answer. Okay. Then sometimes a linear equation may need a couple of steps to solve for x. Okay. For example, you may have an equation of something like this. 2x plus 5 is equal to 17. So here you see that first you have to use addition or subtraction and then division. So these are the two mathematical operators that are required to be able to solve this. So you take the 5 on the other side, on the right hand side, you will have 17 minus 5, which is 12. So that would give you x is equal to 6 as your answer. Divide by 2. So here you see that it has required you to carry out two mathematical operations. Okay. Then you can have an equation in which or which may involve variables on both the sides, left hand side as well as the right hand side. Okay. Consider this. 7x minus 2 is equal to 3x plus 10. Okay. How will you solve this? Well, it requires multiple mathematical operations. Now the trick here is that you should take the variable which is smaller towards a side where you have variable which is larger. So here you have 3x you want to take it on the other side and you want to take 2 on the this side. Okay, so you will have 7x minus 3x will be 4x and 10 plus 2, because 2 will become positive when we take it to the right hand side, will be 12. 4x is equal to 12 will give you x is equal to 3. So x is equal to 3 is your answer here. So you see that it requires more than two operations, two addition, subtractions, and one division. Okay. Now you may have an equation which may require you to carry out distribution or use the distributive property. Okay. All right. So let's say you have an equation of something like this to be solved. So you have 3 brackets x minus 2 is equal to 18. Okay. So here you need to again, excuse me, distribute 3 to both x and 2. The common mistake made by students here is that 3 is distributed to x only and not 2. Okay, we don't want to do that. Okay, so you have 3x minus 6 is equal to 18, or 3x is equal to 18 and 6 is 24. And that would mean your x is equal to 24 by 3, which is 8. So that is your answer. Okay. Now, let us say you have a case where an equation involves fractions. Consider this: x by 3 plus x by 2 is equal to 10. Okay. Now you need to take the LCM, or you can multiply the equation on both the sides by the LCM. Okay. So you will use the knowledge of your rationals. Okay. Here. So let's say the LCM of 3 and 2 is 6. So you can multiply the entire equation by 6. If you did that, you will have 2x plus 3x is equal to 60, or 5x is equal to 60. That will give you x is equal to 12. Okay. That's your answer. Okay. Now you may have situations or special cases when there are either no solutions or infinitely many solutions. When can this happen? You can have no solution, all right, when the given equation results into a false statement. Okay. And you may have infinitely many solutions when the resulting equation will result into an expression which is true always for all values of x. Okay. Now let us take an example of no solution. Okay. So you are given this equation: 3 times x plus 2 is equal to 3x plus 10. Solve for x. Well, you need to distribute 3 on the left hand side first. So which will give you 3x plus 6 is equal to 3x plus 10. So now you see that you have 3x on either side. That means it will cancel out. So what remains is 6 is equal to 10, which is not true or false. So if you result into a false situation, then there cannot be any solution. All right. So there is no solution of this equation. No solution. Okay. Now look at the next case in which you may have infinitely many solutions. Okay. So let's say you have 2 times x plus 3 is equal to 2x plus 6. So when you solve this, apply the distributive property, you will get 2x plus 6 is equal to 2x plus 6, which is always true, no matter what the value of x is. Okay, put any value of x in this, left hand side is always going to be right hand side. Or in other words, this 2x will get cancelled out, and then you get a resultant expression which is 6 is equal to 6. Okay, always true. Okay. So when you have things like these special cases, you can verify this by simplifying it, and if the resultant is false, then there is no solution, and if the resultant is true, then there are infinitely many solutions. Okay. So today we have seen linear equations in one variable. There are different types of problems that come in the set. Equations that can be solved in a single step, 2 steps, involving variables on both sides, involving distribution property, involving fractions, and then either no solution or infinitely many solutions. Okay. Thank you very much.